So welcome back to the video, guys. Last time we talked about multiprocessing and just a basic chicken example where I took a chicken and just cooked it, but we didn't actually get to do anything with that chicken that we cooked. This video we're going to talk about how to actually get that chicken back to some main thread and use the processes to process some input and actually get some output that you can use in your program. So the main structure we're going to be using to pass output from the processes to the main process is something called a queue. And the queue follows the first in, first out principle. Basically, the first element to get enqueued is the first one to get dequeued or taken from the queue. So if you're first in line at a store, you're the first one to be served. The main thing to see here in this diagram is that the flow goes one way. You typically wouldn't use the same queue to go both ways. There is an underlying structure called the pipe, and the pipe is the OS structure that is used to actually pass processes data between the processes, but Python just abstracts that and calls it a queue. You can actually use a pipe to go both ways, and there's a Python library believed to do that, but we won't be covering that in this video. Another thing to see here is that there's some separation. I did put the actual pipe in a different diagram than this little conveyor belt of chicken here. The reason is because the pipe can actually fill up, and if you don't wait for it to be empty, if you don't block, and this is something that comes in built into the library, the chicken that you finish and try to enqueue will be dropped. Luckily, by default, it's not, and it just waits till there's an empty slot. But something to keep in mind, queues can actually fill up. If you're doing a lot of data, pulling a lot of data through, you generally want to put as little data as possible through these inter-process communication pipelines. If it does fill up, bad things can happen. Your task can be dropped, or the pipe can actually break. And this is something that has happened before. I think there's actually 3 implementations of the queue, and I'll go over the ones that seem to be a little more shaky. I don't really know why. I didn't have time to investigate, but essentially you want to keep the queue under control, and the amount of workload passing through it quite low and controlled. And yeah, let's get into actually how to use the queue to pass up the chickens. All right, so we're in our text editor here. I'm going to run through a lot of the basic stuff that we did in the last video. I'm going to set up the chicken example again. So bear in mind, I'm going to pause on the things that are new, however. So from multiprocessing, import process, queue. Queue is a new thing we have here, and this is the queue implementation I was talking about just now. The preferred implementation, however, is something from the multiprocessing class called the managers queue. This one's actually I found to be more reliable, but we're not going to go into that right now. For this tutorial, any of the queue implementations work. I'm just using the one from multiprocessing. So I'm also going to import time, so we can time things. Again, I'm going to define our chef class. Oops. And it's going to have our init method. We're going to also take in a queue this time. That's the same instance we're going to need from the main thread so that they can communicate. And then we're also going to pass in a object that we want to manipulate or process, just for an example. We're also going to have to call the init method for the process class and pass an instance of ourself. And then I'm also going to set the instance of our queue to be the same one as the one passed in. Same with the chicken. Next, I'm going to define some beefy methods, just like a bunch of work. Nonsensical work that it'll do just so that we can see these things in action. And so I'm going to have it cook a chicken for I in range length of chicken. So for each bit in the chicken, make that bit equal to 1. And there's better ways to do this, but I want to intentionally make it more granular and a lot of work for the computer so we can use up all those cores. And then we're going to return the chicken when it's done. Lastly, we're going to define the run method and set some value, cook chicken equal to the method cook chicken output for a raw chicken. And then once that's done, we're going to print out chef is done, finish cooking. And then we're going to enqueue this cooked chicken to the queue we've passed in. So self.queue.put. And remember, this is the same method that I talked about. The same issue, if the queue is full and you don't wait, it will throw out the data you're trying to enqueue. In this instance, that's not a problem. We don't really have that much data. Also, by default, put blocks. So it has this keyword argument here set to, by default, true. And so that's just something to keep in mind. There's also a timeout thing you can look at if the queue never empties, but this is not important for this. So we're just gonna enqueue the cooked chicken, and that's pretty much it. So yeah, let's go ahead and try and run this. One of the things you need to make sure, I didn't really talk about too much last tutorial, was making a guard for your main thread. And it's not really super necessary, but it's good practice. So we're gonna set, if the module name, or I'm sorry, if the process name is main, we're going to, or thread name is main, we're going to run this block. If it's not, if it's a different thread or subprocess, we're not gonna run this block. And this is all the guard is doing. And so first thing I wanna do is set a little timer, timestamp, and then I'm going to make an array for all the objects of the processes that we're gonna run. And then we're going to, and this is the new thing, make a queue object. And so this is just going to be the queue that we're gonna use for all the process. We're gonna pass this reference to all of them. And we're also gonna define the amount of chickens that we wanna cook, just for niceties. Chickens to cook equals 4. We cooked 4 chickens this time. Okay, and then next I'm going to create all these chickens, raw chickens, for iron range chicken to cook. I should call it chickens to cook. And we're going to create a raw chicken. It's going to be a 10 million array of zeros. Hold on, 10. Missing 2 zeros. Okay, and then we're going to append a process of chef process with the queue that we've created, because remember we have to pass that in. And I'm also going to pass in the raw chicken that we want to process or cook. And then we're also going to run all these. So for chef and chefs, chef.start. Usually after this point, so these are all the processes have started. You're gonna want to join just to make sure these finish. For chef and chefs, chef.join. However, in this instance, we don't actually have to do that because we know how many processes are in the queue. We can actually just serve 5 or 4 chickens, dequeue 4 chickens, and know that all the processes have finished executing, and that's when we can exit the program. So we're gonna do something a little different. We're going to say while the chickens to cook is more than 0, we're going to decrement this variable, and during this time we're going to dequeue 4 times, or we will dequeue once in this loop, but throughout the whole loop we're going to dequeue 4 times. So the method that will look like cooked chicken is equal to queue.get. So that's the method that's going to block until there is something available. And you can actually set a timeout here, as I mentioned before. However, it's not really necessary. Keep in mind that if you are waiting for someone and nobody ever there's nothing ever pushed to the queue, you will be waiting forever if you don't put that timeout. So make sure to keep that in mind for your use case. So after the chicken is gotten, and I want to make sure, okay, yeah. After the chicken is gotten, we're going to also print out that we finished getting that chicken, and we're going to make sure that it's cooked. Cooked chicken is equal to, and we're going to print out just 1 bit and make sure that it's 1. So we're going to print out the 59th bit. And yeah, it's going to decrement. And after this is all done, we're going to just print out how long this took. All chefs are finished. And we're going to print out time.time minus the timestamp we took. And we're going to round this all to the nearest hundredths. And see that go. Oh, for I in range. Where do I have that? Name chefs is not defined. I must have spelled it wrong. Chefs. Okay. Cool. So as you can see here, it looks like they all finished cooking. So all these chefs finished cooking around the same time, and then the queue started taking in. It printed out, I guess. They all finished at the same time, and the queue just started printing out the first one that was finished. So looks like all the chickens were cooked, which is a good thing. And yeah, that's about it. So thanks for watching the video, guys. I hope you learned something. If you have any suggestions for what I should cover next, I already have some ideas for the multiprocessing series, but any other type of topics, corner cases, let me know in the comments. I read all of them. So yeah, hope you enjoyed it.